Implementation of AI-driven autonomous systems in military operations by 2028, a comprehensive overview. Introduction. The military landscape is undergoing a transformative shift with the integration of artificial intelligence (AI) and autonomous systems. This report outlines the strategic roadmap for implementing AI-driven autonomous systems in military operations by 2028, structured into 4 key phases and backed by a budget allocation of $500 million for research, development, and integration. This summary synthesizes insights from various sources detailing the anticipated use cases, challenges, and operational implications of this significant initiative. Key phases of implementation. Phase 1, Research and Development, 2024 to 2025. The journey begins with the research and development phase, which will span 2 years. During this phase, the focus will be on fundamental AI technologies. Investment in foundational technologies such as machine learning algorithms, natural language processing, and computer vision will be prioritized. These technologies are crucial for developing systems that can learn from data, make predictions, and operate autonomously. Data processing and cybersecurity. Enhancements in data processing capabilities will ensure that military systems can analyze vast amounts of information in real time. Robust cybersecurity measures will also be implemented to protect sensitive military data and systems from cyber threats. Use cases. Initial use cases will include AI applications for predictive maintenance of military equipment, which can reduce downtime and maintenance costs, and logistics optimization to improve supply chain efficiency. Phase 2, Prototyping and Testing, 2026. Following the R&D phase, 2026 will be dedicated to prototyping and testing. Development of prototypes. Various autonomous systems will be developed, including drones and ground vehicles. These systems will be designed to operate in diverse military scenarios. Simulated environments. Rigorous testing will be conducted in simulated environments to evaluate the performance and reliability of these systems. Critical assessments will focus on scenarios such as reconnaissance missions, supply transport, and battlefield support. Data integration. The emphasis will be on integrating data from multiple sources, including satellite imagery, battlefield intel, and sensor data to enhance decision-making capabilities. Phase 3, Field Integration, 2027. In 2027, successful prototypes will transition into the field integration phase. Operational collaboration. Close collaboration with military units will be essential. Feedback from real-world operations will help refine the systems and address any operational challenges encountered during deployment. Use cases in operations. Key applications will include deploying drones for surveillance missions using AI to support decision-making in command centers and enhancing situational awareness for ground troops. Refinement based on feedback. Continuous feedback loops will be established to ensure that the systems are adaptable and can evolve based on operational needs and challenges. Phase 4, Full Operational Capability, 2028. By 2028, the goal is to achieve full operational capability. Integration into military strategies. Autonomous systems will be fully integrated into military strategies across various branches of the armed forces, enhancing overall operational effectiveness. Comprehensive evaluation. Extensive evaluations will be conducted to assess the performance, adaptability, and interoperability of AI systems in diverse combat environments. Strategic military impact. The successful integration of AI-driven systems is expected to significantly improve operational efficiency, reduce human error, and enhance mission success rates. Common key points across sources. A consensus emerges from various sources regarding the critical importance of data integration. The integration of information from all available data sources is vital for enhancing situational awareness and operational effectiveness. Ethical considerations. The potential ethical implications and operational risks associated with AI systems must be proactively addressed. There is a shared understanding that developing guidelines and frameworks for ethical AI use in military operations is essential to maintain accountability and trust. Differences between sources. While many sources emphasize the technological advancements that AI can bring, some highlight specific regional strategies and military doctrines that may affect deployment timelines. Regional priorities. Certain nations may prioritize air-based drones over ground systems based on their unique operational needs, strategic goals, and existing military capabilities. Military doctrine variability. Differences in military doctrines and operational philosophies may lead to varying emphasis on specific AI applications such as intelligence gathering versus logistical support. Timeline of events. 2024 to 2025, R&D phase focused on foundational technologies and securing funding. 2026, prototyping and testing of autonomous military systems in simulated environments. 2027, field integration of systems into military operations, emphasizing real-time feedback loops for refinement. 2028, achieving full operational capability with comprehensive evaluations and refinements based on extensive operational experience. Conclusion. The integration of AI-driven autonomous systems into military operations by 2028 presents a structured and strategic approach. The roadmap emphasizes research and development, prototyping, testing, and field integration while also addressing ethical considerations and operational risks. With a budget of $500 million allocated for this initiative, military forces are poised to leverage advanced technologies effectively, enhancing their operational capabilities and strategic advantages in an increasingly complex global security environment. This comprehensive overview underscores the importance of a methodical approach to adopting AI technologies in military operations, ensuring that they are not only effective but also aligned with broader ethical and operational frameworks. By 2028, the anticipated outcomes could significantly reshape military operations, leading to more agile, efficient, and capable forces prepared to meet future challenges. The implementation of AI-driven autonomous systems in military operations by 2028 involves several counterintuitive aspects that challenge traditional views on military technology adoption and operational strategy. Here are the key counterintuitive pieces of information identified in the content. 1. Budget allocation versus expected outcomes. While a substantial budget of $500 million is allocated for R&D and integration over 4 years, the anticipated outcomes of this investment may not align with traditional expectations. Historically, military projects have incurred significant overruns and delays, making it plausible that even with this budget, the integration of AI may not achieve the desired operational capabilities by 2028. The assumption that funding directly correlates to successful implementation is thus counterintuitive, as historical precedents show that technological advancement often faces unexpected hurdles. 2. Focus on ethical considerations. The emphasis on addressing ethical considerations and operational risks associated with AI systems is a departure from the conventional military perspective that prioritizes technological superiority and immediate operational effectiveness. This indicates a shift towards a more holistic approach in military planning, where the implications of deploying autonomous systems are acknowledged. The counterintuitive part lies in recognizing that prioritizing ethics and risk management may slow down the implementation process. Contrary to the expectation that faster deployment of technology is the primary goal. 3. Integration of diverse military branches. The goal of achieving interoperability among different branches of the military by 2028 suggests an unusually collaborative approach in a traditionally siloed environment. Counterintuitively, this indicates that despite the competitive nature of military operations, there is a recognition that effective AI integration necessitates cross-branch cooperation. This could lead to challenges in standardization and integration that are often underestimated in military strategy discussions. For real-world feedback loops, in the field integration phase, the reliance on real-world feedback to refine AI systems may seem counterproductive to rapid deployment objectives. Typically, military operations favor pre-deployment testing and validation in controlled environments. The shift towards utilizing operational feedback suggests an understanding that AI systems will require ongoing adjustments based on real-world performance, which complicates the timeline and operational readiness expectations. 5. Diversity in regional strategies. The acknowledgement of differing regional strategies in military doctrines affecting deployment timelines contradicts the notion of a unified global advancement in military AI technology. It highlights that while some nations may rapidly adopt air-based drones, others may prefer ground systems based on specific operational needs. This differentiation in adoption rates and strategies may create unexpected competition and disparities in military capabilities that are not accounted for in a generalized timeline. 6. Technology versus human operators. The anticipated use of AI for decision-making support in command centers suggests a counterintuitive reliance on technology to enhance human decision-making rather than replace it. This reflects a nuanced understanding that while AI can process data and provide insights, the ultimate decisions may still rest with human operators. This challenges the narrative that autonomous systems will fully replace human roles in military operations, emphasizing a partnership model instead. In summary, the implementation of AI-driven autonomous systems in military operations by 2028 reveals several counterintuitive aspects that challenge conventional wisdom regarding military technology adoption, ethical considerations, interbranch collaboration, and the role of human operators in the decision-making process. These insights underscore the complexity of integrating advanced technologies in a traditionally structured and competitive environment. The report on the implementation of AI-driven autonomous systems in military operations by 2028 outlines a structured approach divided into 4 key phases supported by a $500 million budget for R&D and integration. While the core elements are presented clearly, several critical insights and subtleties warrant further examination, as they may be overlooked but hold significant implications for the future of military operations. 1. Emphasis on cybersecurity in R&D phase. One of the less highlighted yet crucial aspects of the initial R&D phase is the focus on robust cybersecurity measures. As military operations increasingly rely on AI and autonomous systems, the threat landscape evolves. Cybersecurity isn't merely an ancillary concern, it is foundational for operational integrity. The potential for adversaries to exploit vulnerabilities in AI systems poses a significant risk. If these systems can be hacked or manipulated, the consequences could be catastrophic, leading to compromised missions or even loss of life. This emphasis on cybersecurity reflects a recognition that the technological arms race is not solely about innovation but also about safeguarding those innovations against malicious actors. The significance of this focus lies in the potential to set a precedent for how military organizations worldwide prioritize cybersecurity in the development of new technologies. 2. Integration of multiple data sources. The report mentions the integration of data from various sources, including satellite imagery and battlefield intelligence, as a critical component of the testing and prototyping phases. However, the implications of this integration are profound. The ability to synthesize large volumes of data in real time can significantly enhance situational awareness, enabling military units to make better informed decisions. What is often overlooked is the challenge of data interoperability and the ethical implications of data use. Different systems may operate on different standards, and combining these disparate datasets could lead to misinterpretations or errors in judgment. Moreover, the ethical considerations surrounding data collection, especially in surveillance contexts, raise questions about privacy and accountability. Understanding these nuances is vital for developing policies that govern the use of AI in military contexts. 3. Feedback loops during field integration. The emphasis on real-time feedback during the field integration phase is another key point that deserves attention. This iterative process allows for the adaptation of AI systems based on actual operational experiences, which is crucial for refining technology. However, The significance of this feedback loop extends beyond mere technological improvement. It embodies a shift in military strategy towards a more agile and responsive operational framework. This adaptive capability may allow military forces to engage in operations that are less predictable and more responsive to changing battlefield conditions. The implications of this shift could transform traditional military hierarchies and decision-making processes, requiring new organizational structures and training protocols to fully leverage the benefits of AI systems. 4. Ethical considerations and operational risks. While the report acknowledges the need for addressing ethical considerations and operational risks, it often remains at a surface level. The rapid deployment of AI in military operations raises fundamental ethical questions about accountability, especially in combat situations. Who is responsible if an autonomous system makes a decision that leads to unintended civilian casualties? The significance of these ethical considerations cannot be understated. As militaries adopt AI technologies, they must also develop frameworks for accountability and transparency. This is especially critical in an age where public scrutiny of military actions is heightened. Failure to adequately address these concerns could lead to public backlash and diminished trust in military institutions. 5. Potential for regional variations in deployment strategies. The report briefly touches on the differences in regional strategies in military doctrines, yet this aspect is often overlooked. The diverse geopolitical landscape means that the deployment of AI systems will not be uniform across nations. Countries may prioritize air-based drones over ground systems based on their unique operational needs and strategic objectives. Understanding these regional variations is significant, as they could lead to asymmetries in military capabilities. Nations that effectively integrate AI-driven systems may gain substantial advantages over those that lag in adoption. This disparity could influence international relations, defense spending, and the nature of conflicts in the coming years. Conclusion. The report presents a comprehensive roadmap for integrating AI-driven autonomous systems into military operations by 2028. However, the nuances surrounding cybersecurity, data integration, feedback mechanisms, ethical considerations, and regional deployment variations are crucial for understanding the broader implications of this initiative. Addressing these overlooked areas will be essential for militaries to not only adopt advanced technologies effectively but also to navigate the moral and strategic complexities that accompany their use. The significance of these issues extends beyond operational efficiency. They touch upon the very foundations of military ethics and international stability in an increasingly automated world. The implementation of AI-driven autonomous systems in military operations by 2028 is a multifaceted initiative that requires careful planning and execution across several key phases. Here are the 4 most valuable points for in-depth analysis and discussion. 1. Research and Development 2024 to 2025. The first phase of implementation is crucial as it lays the groundwork for all subsequent activities. This phase focuses on enhancing AI technologies. The development of advanced machine learning algorithms and data processing capabilities is essential. Innovations in AI will allow military systems to learn from vast amounts of data, improving their decision-making in real-time scenarios. For instance, AI can be used for predictive maintenance of military equipment, reducing downtime and enhancing operational readiness. Cybersecurity measures. As military systems become increasingly reliant on AI, ensuring robust cybersecurity protocols will be vital. Protecting sensitive data and maintaining the integrity of AI systems against cyber threats will be a priority, as vulnerabilities could lead to catastrophic failures in military operations. Logistics optimization. AI can significantly enhance military logistics, enabling more efficient supply chain management and resource allocation. This optimization will ensure that troops have the necessary supplies and equipment when needed, thereby increasing operational effectiveness. 2. Prototyping and testing 2026. The second phase emphasizes the transition from theoretical development to practical application. Creation of prototypes. This involves developing initial prototypes of autonomous systems that can be tested in controlled environments. The focus will be on systems such as drones for reconnaissance missions and autonomous vehicles for logistical support. Rigorous testing. Prototypes must undergo extensive testing to validate their performance across various military scenarios. This phase will provide insights into their capabilities, limitations, and necessary adjustments before field deployment. Testing will include integrating data from multiple sources such as satellite imagery and battlefield intelligence to simulate real-world conditions effectively. Feedback mechanisms. Establishing robust feedback loops during testing is essential. Insights gained from simulated environments will inform further refinements. Ensuring that systems can adapt to dynamic military scenarios. 3. Field Integration 2027. The third phase focuses on integrating tested systems into operational military units. Collaboration with military units. Close cooperation with combat units is essential for successful integration. This collaboration will help identify specific needs and allow for adjustments based on real-world feedback. Deployment of autonomous systems. Systems like drones for surveillance and AI-assisted decision-making tools for command centers will be tested in live operations. This phase serves as a critical bridge between testing and full operational capability, ensuring that systems perform well under actual combat conditions. Addressing operational risks as systems are deployed. It's crucial to address potential operational risks associated with AI. This includes ensuring that autonomous systems can operate safely alongside human personnel and that ethical considerations are integrated into their operational protocols. 4. Full Operational Capability 2028. The final phase aims for the complete integration of AI systems into military operations. Achieving interoperability. By 2028, the goal is to ensure that autonomous systems can operate seamlessly across different branches of the military. This interoperability is critical for coordinated operations and effective resource sharing. Performance evaluation. A comprehensive review of AI system performance and adaptability will be conducted. This evaluation will help determine the effectiveness of AI in diverse combat environments and inform future enhancements or adjustments. Ethical considerations. As military operations increasingly involve AI, addressing ethical implications becomes paramount. Discussions around the use of AI in combat decision-making, autonomy, and accountability must be prioritized to ensure responsible deployment. Conclusion. The implementation of AI-driven autonomous systems in military operations by 2028 is a complex endeavor that involves strategic planning and execution across 4 key phases. Each phase, from research and development to achieving full operational capability, requires careful consideration of technological advancements, operational risks, and ethical implications. The allocated budget of $500 million underscores the importance of this initiative, aiming to leverage advanced technologies for enhanced military effectiveness. By understanding and addressing the challenges and opportunities within these phases, military forces can better prepare for the future of warfare. 1. Project Maven 2017 present. Initiated by the U.S. Department of Defense, Project Maven aims to integrate artificial intelligence into military operations, particularly for analyzing vast amounts of video data collected from drones. The project focuses on developing machine learning algorithms to enhance the military's ability to identify and track objects of interest in real time. This initiative has sparked debates regarding the ethical implications of using AI in warfare, similar to concerns raised in the proposed implementation of AI-driven autonomous systems. 2. DARPA's Autonomous Underwater Vehicle AUV Program 2000s present. The Defense Advanced Research Projects Agency DARPA has invested significantly in developing autonomous underwater vehicles for military applications, including surveillance and reconnaissance missions. The AUV program has gone through various phases of research prototyping and field testing, closely mirroring the structured implementation phases outlined for AI-driven systems in military operations. This program highlights the challenges and advancements in integrating autonomous systems into existing military frameworks. 3. The U.S. Navy's Ghost Fleet Overlord Program 2018-present. This program focuses on developing unmanned surface vessels that can operate autonomously or be remotely controlled. The Ghost Fleet Overlord initiative emphasizes the importance of integrating AI technologies into naval operations, particularly for logistics and support missions. Similar to the proposed timeline for AI-driven systems, the program has phases for development, testing, and operational deployment, showcasing the military's ongoing commitment to leverage autonomous technologies in warfare. Future outlook: predictions for AI-driven autonomous systems in military operations by 2028. The integration of AI-driven autonomous systems into military operations is poised to revolutionize warfare and defense strategies. By 2028, this transformation will likely manifest in several key areas. Driven by the proposed roadmap and budget allocation of $500 million for research, development, and integration. 1. Enhanced decision-making capabilities. By 2028, AI systems will significantly enhance decision-making capabilities in military operations. Leveraging advanced machine learning algorithms, these systems will analyze vast amounts of data from various sources, satellite imagery, reconnaissance reports, and real-time battlefield updates, to provide actionable insights. Commanders will rely on AI to simulate potential outcomes of different strategies, enabling them to make informed decisions quickly. The predictive maintenance of equipment will also minimize downtime, allowing for more efficient resource allocation during critical missions. 2. Autonomous operations and reduced human risk. The deployment of autonomous systems will lead to a reduction in human risk during military operations. Drones and unmanned ground vehicles (UGVs) are expected to take on high-risk roles such as reconnaissance, surveillance, and supply transport in hostile environments. By 2028, these systems will be able to operate with a high degree of autonomy, performing missions without direct human oversight. This shift will not only protect military personnel but also allow for more daring operations that would otherwise be deemed too risky. 3. Interoperability among military branches. The transition to AI-driven systems will emphasize interoperability among different military branches. By 2028, we can expect a unified approach where air, land, and naval forces utilize a common framework for AI applications. This interoperability will facilitate coordinated operations, improving the overall effectiveness of military strategies. For instance, air-based drones will work in tandem with ground-based AI systems to provide comprehensive situational awareness and strike capabilities. 4. Ethical and regulatory frameworks. As AI systems become more prevalent in military operations, the establishment of ethical and regulatory frameworks will become imperative. By 2028, military organizations will need to address concerns regarding the use of autonomous weapons systems, including accountability for actions taken by AI. Discussions around the ethical implications of AI in warfare will lead to the formulation of guidelines that ensure compliance with international humanitarian law and minimize collateral damage. 5. Continuous learning and adaptability. AI-driven systems will possess the capability for continuous learning and adaptability by 2028. These systems will refine their algorithms based on operational feedback, improving their effectiveness in diverse combat scenarios. As military tactics and environments evolve, AI will adapt in real time, ensuring that military operations remain agile and responsive to changing conditions. This adaptability will be crucial for maintaining a strategic advantage on the battlefield. 6. Potential for cybersecurity threats. As military operations increasingly rely on AI and autonomous systems, cybersecurity will be a critical concern. By 2028, adversaries may exploit vulnerabilities in these systems. leading to potential threats that could compromise missions or national security. Therefore, a significant focus will be placed on developing robust cybersecurity measures to safeguard AI-driven systems against hacking and other cyber threats. 7. Increased investment in R&D and talent acquisition. To realize the ambitious goals set for 2028, there will be a concerted effort to increase investment in R&D and talent acquisition. The allocated budget of $500 million will be just the beginning as military organizations recognize the need for ongoing funding to stay at the forefront of AI technology. Moreover, attracting top talent in AI data science and cybersecurity will be essential to drive innovation and ensure effective integration of these systems into military operations. Conclusion: the future of military operations with AI-driven autonomous systems by 2028 holds great promise. Enhanced decision-making capabilities, reduced human risk, interoperability among branches, and ethical frameworks will shape a new era of warfare. However, challenges such as cybersecurity threats and the need for continuous learning must be addressed proactively. The strategic allocation of resources and a clear roadmap will be crucial in navigating this transformation, ultimately leading to more effective and agile military operations. As these systems become integral to defense strategies, the military will not only adapt to technological advancements but will also redefine the nature of warfare itself.